Hello everyone, my name is Ihab. I'm the founder of Airball, and I'd like to welcome you to our testing team. And today I'd like to give you a few ideas on how you can set up this Airball system that you just received. And so without further ado, let's get right to it. This, as you might imagine, is the Airball probe. It is the core of the system, and its job is to send air data to anybody who's listening over Wi-Fi. You'll notice it has a series of holes at the front. These holes are connected to a series of pressure sensors. There's a static probe. There's no hole at the end of this. There's just holes at the periphery that measure static pressure. And if you look carefully here, there's a teeny tiny thermometer. So this gets all kinds of interesting information, sends it out over Wi-Fi. You can see the antenna right here, and it's battery powered. This has a USB-C charging port at the back and an on-off switch also in the back. Pushing the switch towards the center turns it on, pushing it towards the outside turns it off. There are a series of LEDs. There's a red LED which blinks when it's sending data. There's an orange LED which is on when the probe is powered on. There's also a yellow LED that you can't quite see here, which is on when the probe is receiving current from the USB connection. And there's also a blue LED that's on when the probe is charging. Now remember, when you connect this to USB, this power switch has to be in the on position in order for it to charge. When fully charged, this probe has been clocked at about 18 hours of battery life, but we recommend basically 12 hours, so basically a day's worth of flying. Now, this probe needs to be aligned with your airplane in order to work properly, and there are two main points of alignment. First, it must sit vertically in the plane of your airplane as you fly, and second, it must not be yawed left or right relative to your airplane. And finally, but this is not so important, it should point right about the same level as the fuselage of your airplane, but a few degrees misalignment is fine because angle of attack really is kind of a relative thing. So wherever it ends up is just fine. The probe that we sent you is accompanied by a mounting that works on your wing strut. And so I'm going to show you the version of the mounting we're shipping out right now, and then I'm going to show you a slightly improved mounting that you may receive in the mail soon. So the mounting is basically a clamp with a V-block and a little back part here that sticks over your strut. And it has, at least in its current form, a ram mount ball right here. So imagine this is your wing strut. You're going to want to place this over the front of your wing strut, place this over the back, slide it until it's secure, and then using the provided bungee cords, you want to go from back to front, looping the bungee cords around, and make sure that you tighten the bungee cords as necessary. You can change their length to suit your airplane so that it's secure but not excessively tight. And you want it to be really nice and snug. And once on, this thing is really, really secure. We've been flying with designs such as this for many, many years, and you'll notice this is really held on tight. So then you want to attach the ram mount parts next. So you have a ram arm right here, and you also have an adapter plate for the probe. So first let's talk about how you attach the probe to the adapter plate. Notice the probe has a couple of bolts coming out of it. The adapter plate has two slots that match these bolts. So slide the bolts onto the adapter plate like this and snug it down. And then you have a number 8 screw that's attached to a little thumb screw. So you push that into the hole here, make sure it goes all the way into the probe, and screw it in until it is finger tight. And when it is tight, it pulls the probe both down and in so that it's a very secure return to zero mount for the probe. All right. So now we're going to attach this to the strut mount with the ram arm, and that should be easy for anyone who's familiar with ram mounts and their operation. And so here we go. All right. Now, with the probe attached to your airplane in this way, if you wish to remove the probe from your airplane, you don't mess with this. Instead, what you do is you unscrew this screw here, and then you pull the probe off, and then when you put it back, it returns to the exact 0 that it was at before. Okay? Now, we still haven't talked about how to align it with your airplane. And so there's kind of a calibration process, or a bore sighting process, as it were, that we've designed. So take your plane out to somewhere where it is sitting wings level, and have it so that it's pointed at a distant object. And that needs to be basically at optical infinity. So like look for a mountain or a building that's far away, and make sure the airplane fuselage is sighted straight down in whatever way you can. You can sight down the fin and the tip of a rivet on the fuselage or something, but just sight down at this object. Now, we provide a bore sighting attachment with the probe, and you notice it has a spirit level over here and what looks like sort of a vertical peep sight, and over here it has a corresponding vertical oval, and there's a little red dot or colored dot with a fiber optic illumination. So if you look through that, you can see that you can line up the vertical parts together and then use that dot for sighting, and you can move up or down as necessary to get that dot wherever you want. So here you go, you should see it pretty lined up, and then you can move up or down and keep the dot centered and line up this as a, basically as a bow hunting sight or a bow sight. And then you can use the spirit level to level this, to level your probe. All right, so now let's look at the bottom of the probe. You will notice in the gray 3D printed parts at the top and bottom of the probe, there's a tiny little notch that you can use to align your parts. And here we're going to take out the screw, pop off the probe, and notice there's a notch right here and a notch right there. They're a little bit subtle, but you should be able to see them. So these define the keel line of the probe, the center line. And so you want to take this attachment and have it facing backwards. You want the spirit level on the back of the probe, and you want to align the little notch here with the keel line of the probe, and then take the provided rubber bands and attach the sighting arrangement to the probe. And I'll do that in a second, and you'll be able to see. So here's one rubber band, and we can use the other rubber band, and Bob's your uncle. All right, so now basically once you've centered this on the probe, you have turned the whole probe into a little bow sight, and you can sight down this little contraption and align the probe appropriately, right? So we'll put it back, and I'm going to pretend that this is my strut, and I've actually tightened the screw, and I'm going to sight at my distant object and look down these sights, loosen the mount a little bit, twist the probe so that the spirit level is level, use the sight to sight down at the object, moving my head up and down as necessary because the object may be high or low in elevation, and then in the process also look to the side. Notice how my probe is lying, set it up so that it's about down the center line of the fuselage, just down some kind of center line you can see that makes sense, and then go back and make sure that all the other adjustments are working. And eventually you should be able to get it to a point where it is well aligned, and then tighten this, and you're good to go. All right, now you can always remove the probe from the mount. You can also remove the bore sighting attachment, and now you have this. You can take it and charge it, put it back on your airplane, and life should be good. All right, so now we have a working probe that's mounted on our airplane, and it's pointed more or less straight ahead in angle of attack, straight ahead in yaw, and it's level with the wings. So now you should have a good reference point for your data. The other thing you got with your kit was the Airball display. Here it is right here. This Airball display works with any kind of USB power source. I'm using a USB battery here, and you can see that it's receiving data from the probe right now. So I'm going to take the probe off of its mount and blow into the center hole, and notice what happens. Notice as it detects dynamic pressure, the ball increases in size because the white ball has a diameter that's proportional to your indicated airspeed and an area that's proportional to dynamic pressure for you, those of you who like the engineering of it. There is also an angle of attack factor to it, so if I pretend to be blowing on this from below, notice the ball is down below, indicating a relative wind coming from below the airplane, and if I blow on it, pretending it's being blown at from one side or the other. Sorry, this one's super hard. There you go, you can see the effect of yaw. So this was the airplane yawed to the left, the wind is coming from the right, and so the ball here showed up on the right. Okay? So there's also a little altimeter down here. This displays the altitude in feet. This displays your barometer setting. And this little line that goes up and down is a pointer that gives you your climb rate. So these little ticks here and there are plus or minus 500 feet per minute. And anything more than that, you notice the pointer kind of folds up against the top. Here, I'm going to show you by sucking on the little static probe. Notice how for small deflections the pointer is horizontal and then it kind of folds up for large deflections. So this is just our way of getting an altimeter into this very small space because, after all, we can get all that information from the probe. On the probe, there are also these annunciators which you can adjust. You can adjust the position of these. The little cups right here, usually we set that to glide speed. The ramps here are usually set to the best angle of climb, angle of attack, and the little angel wings here are usually set to the best rate of climb, angle of attack, and you can calibrate that by doing a test flight on your airplane. In order to control the parameters of this, you need to have a phone and you need to use the Wi-Fi connection on your phone. So you notice that this is Airball serial number 0015. You would expect to find a Wi-Fi hotspot called Airball 0015 if you were to go to your phone. And in fact, I'll whip out my phone right now and show you. And here right there you can see there is, sorry for the bad picture quality, but there's a Wi-Fi hotspot called Airball 0015, and I'm going to go to that. The password is relative wind. Right here. Right there, you can see it, relative wind, all lowercase, and we connect. And once we're connected, your phone may complain to you that this Wi-Fi base station does not have internet. Of course it doesn't, it's just an Airball probe. Now I'm going to go to my web browser, and I'm going to go to an IP address, for those of you in the know, 192.168.4.1. I'm going to show you how I do that. So wherever you'd normally type google.com or any other kind of address, just type 192.168.4.1 and click OK. And lo and behold, you get the Airball settings editor. Now this allows you to change all the parameters of the probe, or actually of the display, as much as you wish. There are alpha values here that you can change, beta values, which are angle of yaw, and V values, which are the dynamic pressure limits. There's also a choice of what sound scheme you want to use. There are two sound schemes, fly on speed and stall fence, which are different ways of visualizing the angle of attack and yaw as sound. You can change the audio volume. You can change the barometer setting, you can decide whether or not you want the altimeter, and you can decide on the amount of smoothing you want on the vertical speed and on the position of the bowl. I'd like to demonstrate to you the control over the display, so I'm going to drag my things over here. The easiest and most immediate thing is I can click Show Altimeter On and Off, and you can see that if I click the radio button, the altimeter goes on or off. I can also change some of these values. So for example, alpha Y, this should now change the little ramps. I'm sorry, the little angel wings. Now they're moving down. Now they're moving up. And the numbers here are alpha X, alpha Y, alpha reference, which is the little glide symbol here, alpha crit, which is where the horizontal red line is at the bottom. That should represent stall. Alpha min, which is the alpha at the top of your display. And then beta full scale and beta bias, should you have to change the bias if your yaw is a little bit off. And then a bunch of V speeds. Most of these should be self-explanatory. I think once you're at the point where you can start using this, we can have another discussion when you could get more refined with how to set these. But right now, this should get you started. Please let me know if you have questions, and we'll take it from there. Thank you very much.